Hey everyone, welcome to my YouTube channel, the Print Lab Chronicles, a place where we'll learn about 3D printing together. I'm just starting out and I'll be sharing my honest journey, the wins, the fails, and all the lessons in between. If you have ever been curious about 3D printing, or if you are a seasoned maker with tips to share, I would love for you to join me. Don't forget, you can find timestamps in the description below to jump to specific topics. Last time, we peeled back the layers of FDM 3D printing, the type most people envision when they think of 3D printing. We talked about how it builds objects by melting plastic filament layer by layer and why it's such a fantastic starting point for makers. If you missed it, I will put a link on the top right. Now, if you stuck around to the end of that video, you know I teased something different. Something that achieves levels of details and surface smoothness that can truly blow you away. Today, we are diving headfirst into that fascinating world, resin 3D printing, predominantly known through its two main technologies, SLA, stereolithography, and DLP, digital light processing. Get ready to see how light can create magic. So, what exactly is resin 3D printing and how does it differ fundamentally from FDM? Well, instead of plastic filament, resin printers use a special liquid, light sensitive material called photopolymer resin. This resin has a remarkable property. When exposed to a specific wavelength of light, typically ultraviolet or UV light, it hardens or cures. The two primary types you will encounter are SLA and DLP. SLA stands for stereolithography, and it was actually the very first 3D printer technology ever invented. It uses a highly precise UV laser to draw out each layer onto the surface of the resin. DLP, or digital light processing, is a newer approach that uses a digital projector screen, like the ones in movie theaters, to flash an entire image of each layer all at once. There's also an evolution of DLP called LCD, resin printing, which uses an LCD screen to block UV light selectively. While the light source differs, the fundamental principle remains the same: selectively hardening liquid resin, layer by incredibly thin layer, to build a project from the bottom up. Let's break down the mesmerizing process of how a resin printer brings a digital model to life. The resin vat. Your liquid photopolymer resin sits in a transparent vat, often with a special nonstick film, usually FEP, fluorinated ethylene propylene, at the bottom. This film is crucial because it allows the light to pass through but prevents the cured resin from sticking permanently to the bottom of the vat. The build plate. A perforated metal plate called build plate is lowered into the resin just a hair's breadth above the FEP film. This plate is where your print will actually form. The light source. Magic time. Below the vat, either a precise UV laser for SLA or a high resolution LCD DLP projector shines the UV light up through the FEP film. This light flashes the exact shape of your first layer of your 3D model, curing the layer. Where the UV light hits the liquid resin, it instantly cures and solidifies, forming the first incredibly thin layer of your object. Peeling and lifting. Once that layer is complete, the build plate lifts upwards, carefully peeling the freshly cured layer away from the FEP film. This peel action can sometimes create a soft sound, almost like a faint pop. This lift also allows fresh liquid resin to flow underneath the newly formed layer. Repeating the process, the build plate then lowers back down just a fraction of millimeter above the previous layer, and the light source flashes the next layer's image. This process repeats layer after tiny layer, with each layer bonding perfectly to the one below it, gradually building your object from the bottom up until your digital design becomes a real, tangible, and often stunningly detailed thing. Now, let's talk about why would you choose this technology. Resin 3D printing truly excels where FDM has its limitations. Here are the biggest advantages: unrivaled detail and surface smoothness. This is the undisputed champion feature of resin printing because resin printers can achieve incredibly small layer heights, often down to zero point zero 0.01 to zero point zero 0.05 millimeters, which is thinner than a human hair, and the entire layer is cured simultaneously. You get prints with virtually invisible layer lines. The surfaces are incredibly smooth, almost injection molded quality, right off the printer. This precision allows for the capture of the most intricate textures, sharpest edges, and delicate features imaginable. High precision and accuracy. If your project demands very tight tolerances and exact dimensional accuracy, resin printing delivers. The cured layers are very precise, making it ideal for interlocking parts or highly calibrated components. Perfect for small, intricate objects. This is where resin truly shines. Think about hobbyists printing highly detailed miniatures for tabletop gaming, jewelers creating intricate wax patterns for casting, dental labs making precise models, or engineers prototyping tiny, complex mechanical parts. If you need tiny, beautiful, and highly accurate objects, resin is your go to. Isotropic properties, unlike FDM prints, which can sometimes exhibit weaker mechanical properties along their layer lines, resin prints tend to have more uniform or isotropic strengths in all directions once fully cured. This can be beneficial for certain functional applications where consistent strength is required. Variety of specialized resins. While we mentioned the broader range of FDM filaments, the world of resin offers specialized options too. There are standard resins, tough resins for more durable parts, flexible resins for bendable objects, castable resins for jewelry making, and even biocompatible resins for dental or medical applications. As amazing as resin printing is, it's not without its challenges. It's important to understand these before you dive in. Mess and material handling. Let's be honest, liquid resin can be messy. It's sticky, it drips, and it needs careful handling. Spills happen, and cleaning them up requires a bit more effort than brushing off FDM filament scraps. This isn't a technology you will want to use in your carpeted living room. You will need a dedicated, easy to clean workspace. Extensive post processing. Prints don't come off the printer ready to use. They are covered in uncured resin and need a multi step post processing routine. Washing. The print must be thoroughly washed, usually in isopropyl alcohol, IPA, or a specialized resin cleaner to remove all the liquid resin residue. Support removal. Just like FDM, resin prints often require support structures to prevent sagging. These delicate supports also need to be carefully removed after washing. Final curing. After washing, the print needs to be exposed to UV light for final complete cure. This significantly hardens the print and improves its mechanical properties. This often requires a dedicated wash and cure station. Safety precautions are non negotiable. Resin is a chemical irritant. It's crucial to wear personal protective equipment (PPE). Nitrile gloves. Always wear gloves when handling liquid resin or uncured prints. Eye protection. Safety glasses are a must to protect your eyes from splashes. Ventilation. Work in a well ventilated area or ideally use a fume extractor as resin fumes can be irritating. Proper ventilation helps dissipate any unpleasant odors and ensures a safer environment. Material cost. Resin is generally more expensive per kilogram compared to FDM filament. This can impact the cost of your prints, especially if you are printing large objects or frequently. Smaller build volumes. Most entry level and mid range resin printers typically have smaller build areas compared to their FDM counterparts. This means you might need to print larger objects in multiple parts. Cold sensitivity. Resins can be sensitive to temperature. If your workspace is too cold, the resin might become too viscous, leading to print failures. Many users need to consider heating solutions for their resin. So, with all that in mind, how do you decide between an FDM and a resin printer? It really boils down to your primary project needs. Choose resin if your priority is unparalleled detail, super smooth surfaces, and high precision. This makes it ideal for miniatures, jewelry, intricate display models, prototypes that need a flawless finish, or highly detailed functional components where aesthetics are paramount. Choose FDM if you need to print larger objects, functional parts that prioritize strength and cost effectiveness over surface finish, or if you prefer a cleaner, less involved printing and post processing experience. It's great for tools, enclosures, cosplay props, and general purpose prototypes. Many seasoned makers usually have both types of printers, an FDM machine for those robust everyday prints and large items, and a resin printer for those highly detailed showcase pieces. It's about having the right tool for the right job. Resin 3D printing is a truly amazing technology that opens up a whole new world of possibilities, especially if you are passionate about fine details and aesthetic perfection. While it comes with a few more steps and safety considerations, the results can be absolutely breathtaking. Now that we have explored the two major types of desktop 3D printers, it's time for exciting part, choosing which one to bring home. In our very next video, I'm going to share my top FDM 3D printer recommendations specifically for new makers. And I'll walk you through why I choose the printer I did for my own journey here at the Print Lab Chronicles. It's going to be a crucial step in building your foundation. If this deep dive into resin printing sparked your curiosity, and if you are now even more excited about getting your own 3D printer, make sure to hit that subscribe button and ring the notification bell so you don't miss any future episodes. And as always, I want to hear from you. What kind of projects are you hoping to make with a resin printer? Or do you have any safety tips for beginners getting into it? Drop your thoughts in the comments below. Your input helps grow this community, and I'm here to learn from you too. Thanks for watching the Print Lab Chronicles. See you in the next one.